going to the next technique, which is your integration by parts. So I think this one is coming from your chain rule or product rule from your derivatives. So if you try to determine the process for your product rule, so coming from your derivatives, so uv. So I think the derivative for this one is u dv minus v du plus the plus v du. So if we try to get the integral for this one, so as you can see in, so if you want to get the integral, okay, so we can get the integral of one portion. Let's say this one. Let's say the u part. So we can isolate one portion and let the other side be uv minus the integral of v du. So um, I think this one is an easy process because you just have to determine u and then determine dv. Because what's important here is you want to achieve this portion here on the left side. So on the right side is, I think the right side is the output of the formula or the outcome of the formula. So let's say that's the answer of the formula. So marara siya kanang the integral of cosine theta is equal to sine theta plus c. So kaninyohang integral of cosine theta is this portion, and then the answer for that integral is this one. Siya, formula pa na siya basihan. Okay, so the purpose of having integration by parts is if you have, so you'll be using integration by parts if you have two different types of functions. So what do I mean by that is, for example, you have integral of x, then so this one is algebraic function, then it's multiplied with sine 2x. So for example, this one. Diba? So sine 2x is a trigo function. So trigo against algebra. So there's no other technique that we can use except for integration by parts. So usually this is the main purpose of the integration by parts. So if you have two different functions, so you have to utilize the integration by parts technique. So it may be algebraic against exponential expressions. It may be logarithmic against trigonometric functions, inverse functions against algebraic functions, so on and so forth. Okay, so tips here is in choosing your u and your dv. So again, we need to choose u and dv because it will represent the formula later. Okay, so the tips here is dx is always included in dv. So dx is always included in dv. So later on we can try to identify that one. So it must always be possible that your dv can be integrated directly. So your dv can be integrated always. And then it's best to choose the most complicated factor as your dv. So your dv should be complicated, but your u parameter is simple. So ato na siya makitaan nga no. So just try to go back to the recording later and identify these three important tips as we go along with our discussion. Okay, so again, as you can see in the bottom part, so product of different functions. So primarily this is the use of your integration by parts. It may be used on logarithms and your inverse trigonometric functions. Okay, so let's discuss 9. So if kaya 9, so let's try 9. So as you can see here, you have two different functions. So one is algebraic, the x term. The other one is your exponential function. So again, as the tip in the previous slide states, always choose the dv as your complicated factor or complicated term. So what we need to do here is, the first step is again to observe the equation if it's two different functions, if it's logarithmic or if it's inverse function. The next step is for us to write u, diba? So the procedure states that we need to identify u and dv. So what you need to do here is start off with your u and then try to write dv on in this manner, because it will, so it has a purpose why we wrote it in this manner. So again, choose, your dv has always dx, so meaning complicated factor plus the dx. So for example, our complicated factor is e to the power of 2x dx. Alright? And the simple term goes to the x variable. Okay, so again, the tip from the previous slide states that your dv can be integrated, and it can be, it can be integrated and it should be the complicated factor. So looking at the dv here, that's e raised to 2x dx. So if we try to integrate this one, so integrating, so this becomes v is equal to 1 half e to the power of 2x. So wala say plus c, kay we can just incorporate plus c later. So sakto ba, di ba? So if we try to derive 1 half e to the power of 2x, that's eu du. So e 1 half e to the 2x times 2. So the final answer is e to x. So our integration is correct. So next is we get the du here. Du is equal to dx. Okay, so after identifying the u, the dv, so next is we need to use the formula. So the formula, so coming from the format, that's uv minus the integral of v du. So starting off with the u first, so let's go back to the red pen. So starting off with your u, that will be x, then times the v is 1 half e to the power of 2x minus the integral of v, that will be 1 half e to the power of 2x, and then your du is dx. So notice that we can now simplify this one even further. So this one is 1 half x e to the power of 2x, then getting 1 half outside the integral symbol, this becomes e to the power of 2x dx. So as you can see, we can fully integrate this one because this one is a basic formula. Integral of e to the power of u is equal to eu plus c. But again, since we have a coefficient, so that will be 1 over a e to the power of au. Okay, so the answer is 1 half times x e to the power of 2x minus 1 half times 1/2 e to the power of 2x plus c. So the final answer is 1/2 x e to the power of 2x minus 1/4 e to the power of 2x plus c. So this is the final answer. Or if you want to factor out e to the power of 2x, so you can do that one also. E to the power of 2x, 1/2 x minus 1/4 plus c. Pwede po siya na. So or. So again, if you're confused why this became 1/2 over 1/2 times e to the power of 2x. So again, the formula is e to the power of u is equal to eu plus c. But that's the formula. So this one is only true for a coefficient of 1. So if you have a coefficient in the exponent, so the real formula is e to the power of au is du is equal to 1 over a e to the power of au plus c. So I think this one is the same as your trig functions. So the angle of the trig functions having a coefficient, di ba? Katong mga, for example, the sine au. So it becomes negative 1 over a cosine au plus c. So that's the same idea as your trigonometric functions having coefficients in the angle. But this time in your exponential functions, the coefficient is in the exponent only. Alright, so questions or clarifications? So that's the whole process. So identifying first u and dv, and then integrating dv and deriving du, and then applying it in the formula. Okay, so let's try the next example. So let's try to be more specific this time. So again, starting off with your x. So x term here is algebraic. The other term is trigonometric. So it's obvious that we have two different functions. So what do we mean by functions? So two different types, di ba? X. So x is not the same as your trigo. So trigo is in second. Okay. So first we need to do is we need to set up our u and dv. So u first and then dv is in this direction here. dv. So again, we can choose the complicated term as your dv. So x, I think the most complicated is secant squared x compared to x. Okay, so this one is secant squared x dx. Okay, and then this one will be our x. So of course, if you want to try to explore, if you want to explore that your dv is x dx, so it can still be integrated, diba? But if you place your u as your secant squared x, so I think you'll be having a hard time deriving your secant squared x. Diba? Murag, I think mas lisod siya. So just try to explore this one later. So for you to be able to clearly see the different values, so let's try another color. So integrating secant squared x, so this becomes tangent x, diba? So derivative of tangent x is secant squared x, so I think that's correct. And then your du is equal to dx. So I think mas makita na ninyo ang formula, di ba? Okay, so by formula, so let's try to write another color. So uv minus integral of v du. So starting off with uv first. So x tangent x minus the integral of v du. So tangent x and then dx. Okay, so I think you have a formula for your tangent integral for tangent x. So x tangent x minus, I think it's ln, I think. So let's try to verify if it's ln. So atong tanaw na if it's gone. If sakto kay I forgot also. Okay, so that will be ln of secant x. Sakto ba? Okay, so that's the final answer. So dali ra siya, no? If you come to think of it. So I think I think another tip here is you can integrate your dv, you can integrate the complicated term, and you can also derive easily. So in this part here, so you can integrate, then you can derive easily. Because if you place secant squared x here, so I think murag lisod siya i-derive, di ba? But if you place x here, x dx here, so you can have x squared over 2. So okay ra siya, di ba? But for secant squared x, so I think the derivative for this one is murag lisod, di ba? Because murag wa siya derivative, but you have a derivative for secant x, but you don't have any derivative for secant squared x. So murag mo na siya ang kwan inyong ma-discover as you go along with examples. All right. So let's go to the third example. So ln, so integral of ln of x. So again, we don't. So looking at the given equation, so we have a logarithmic term here. So asa man siya multiply? Why can we use the integration by parts? So of course, it's being multiplied by 1, which is algebraic. 1 times ln of x. Okay. So we set up our u and dv. So u, and then on this side here is a dv. So again, choose the complicated term as your dv and your derivative as the other term. So if we try to place ln x here, then dx. So notice that we don't have any formula for its integral. Diba? What an integral for ln? We don't have any integral for ln. So meaning we cannot place ln x here. So we place ln x in u instead, because I think we can easily derive this one. Diba? This one becomes du over u. So meaning this one is dx. Okay, so in the green color, so your v becomes x parameter, and then your du. So again, the derivative of ln coming from your calculus 1, that's du over u. So that's dx all over the x value. So again, if you want to verify the terms being presented, so you can always try to reverse the process, diba? So let's say coming from dx over x, if you want to integrate this one, it will lead us back to ln x. So deriving ln x, so it will lead us back to dx over x. So same goes for the right side here, the v variables. So the integral of dx is x, the derivative of x is dx. So using the formula, the uv minus the integral of v du. So u is ln x times x minus the integral of v du. So x and then du is x all over x. So we can cancel out the x here. So what's left is x ln of x minus the integral of dx. So we have x ln x minus x plus c. So this could be one answer. So pwede rin po siya ma-accept as an answer. You can also have this answer as well. X times ln of x minus 1 plus c. So you can also have this answer here, or. Okay, so questions? So Marag, I think for me the the placement of your u and your dv. So it could be that it may be the complicated term, but it's difficult to integrate, diba? As mentioned earlier. So if we try to place ln dx here, so it's difficult, diba? Because we don't have any formula for the integral of ln. And if we place 1 here, so the derivative of 1 is 0. So mabutlog siya, di ba? So we don't have any value in our integral later because we need to multiply it with du as well. So mara siya kanang kuan. So getting the complicated term, but of course your complicated term can be integrated. All right. So let's proceed to the fourth example. So let's try utilizing the arctangent or the inverse trigonometric functions. So as you can see here, you have to deal with the inverse trigonometric function. And as per what we have discussed so far, there's no formula for arctangent square root of x. But we do have an integral that leads us to the inverse arctangent. So again, this one is being multiplied by 1. So that's why it's still applicable for integration by parts. Okay, so writing u and v first, u, and then dv. Okay, so again, if we try to place arctangent square root of x here, dx, so we don't have any integral for the arctangent or the inverse tangent. So di siya pwede, di ba? So of course, there's no other way but to place it in the u function. So this becomes arctangent square root of x, and then your dv is your dx. Okay, so determining now the du and v. So let's start off with the v first. So integral of dx is x. The derivative of arctangent square root of x. So if you recall your formula from your derivatives, so this becomes dx all over, di ba? Unsa ito? 1 plus x. So why it's 1 plus x? So again, coming from your derivatives, so arctangent u over a. So the derivative for this one is du all over a squared plus u squared, di ba? If I'm not mistaken. So I think that's the derivative as far as I can remember also. So just try to verify this one if I am not correct. So next is you write the formula for u to be guided. V and du. Okay, so we go to the uv first. So x arctangent x. So I just immediately make it in order. Then divided by x and times dx all over 1 plus x. Okay, so multiplying by x, so this becomes x arctangent square root of x minus the integral of x dx all over 1 plus x. So how do we deal with the right integral? So recall that we can divide this one because the numerator is the same as the degree in the denominator. So dividing, so I'm going to use lighter green lang. So 1 plus x, this one is x, so this one is 1. X plus 1, then minus, then we have negative 1. So the answer for this one is 1 minus 1 over 1 plus x. Okay, so this becomes x arctangent square root of x minus the integral of, so instead of this term here, this becomes 1 minus 1 over 1 plus x dx. And I think you can now integrate this one. So this becomes x arctangent square root of x, then minus x, then plus ln of 1 plus x. So let me just clean this up. So 1 plus x plus c. Ano? So mag-hold kayo siya, no? So ato lang tarong na. So x, then arctangent square root of x minus x plus ln of 1 plus x plus c. So this is the final answer. So if you're wondering why I got ln 1 plus x, so marag tungod na po na sa years of experience. So if you want to go very basic, so you can use sub technique. So let u be 1 plus x here, then du is equal to dx. So this becomes the integral of du all over u. Mananay mo siyang ln 1 plus x. So I hope you understood why name mo siyang ln of 1 plus x. Okay, so questions? Do you have questions? Questions or gutom na no? So dili negative ang ln. So dili siya negative because dili lang, bitaw joke lang. So di siya negative because negative here, negative sign here. Then negative, di ba? Negative x. Then negative times negative, muna may mo siyang positive ln of 1 plus x. So muna siya. So murag lagi ang lagi ang presentation no. Kaya mo ani jud siguro na ang Google Meet. So muna mag-record ko sa OBS para i-upload sa YouTube kay mag smooth ang iyahang kuan. So murag para na ako mura siya kanang sa ito kana na ay murag buwak-buwak ang iyang pagsuwat ba. Okay, so let's proceed to number 5. So para mahumatag sa'yo. So the integral of cosine x times ln of sine x dx. So murag nagka-complicate nagsamot ang atong mga expressions. So again, this one is a trigo function against a logarithmic function. So with experience, or I mean if with experience and also with knowledge, so if you know that you can't integrate ln, so automatically mahimo siyang u, di ba? Because we cannot integrate ln because we don't have any formula for the integral of ln. So our v, So our v is dv, I mean, is the other component which is cosine x dx. So by integration, I mean by the integration, so our dv becomes, so integral of cosine is sine x, and then the derivative of ln is du over u. So du, that will be cosine x all over sine x dx. Magana siya, di ba? So again, if you want to verify, so vice versa, so derivative of ln x is this one. Then if you want to integrate, you go back to ln sine x. So I think ln sine x is the formula for the integral of cotangent x, diba? Because cosine over x over sine x is cotangent x. So integral of cosine x is sine x, derivative of sine x is cosine x dx. So sakto, di ba? So for verification, so always do that part. So by formula, this is the formula. So starting off with uv, so we're going to have sine x. So ako lang siyang in-order daan ha. Okay, but itanawon because it's weird that the ln is in the first portion, then the next term is the trigo function. Okay, minus v du sine x, then times the du cosine x sine x dx. So we can cancel out sine x. So we have sine x ln of sine x minus the integral of cosine x dx. So since this one is a simple term already, so this one is sine x ln of sine x minus sine x plus c. So you can factor out sine x. So you can also have this answer. So I can give you the full credit for this answer. But if you want to simplify it, so this one is the final version. So sine x. So bracket lang siya, bracket eh. Oops, sorry. So ato lang tarong una kay para nindot og dagway. So minus 1, then plus c. So or na siya, or. Okay, so questions so far? Okay, so there's no question. So let's proceed with the next example. So how about secant cube x dx? So how are we going to utilize the integration by parts here? So of course, we can break this one into its corresponding sa ato ning colored. So we can break this one into its components. So secant x, then the other one is secant squared x dx. So aside from using the transformation by trigonometric functions katong type A, B, and C, so you can also use integration by parts, but I think the process for integration by parts here is maybe for you it's complicated because you want to be safe with your calculations. But this is another method in solving your type P. So you can use integration by parts. Okay, so you want your u to be something, and then you dv as something also. So observing the two terms, so what's best for dv and what's best for the u parameter? So looking at secant, so I think it's impossible to integrate secant because we don't have any formula for secant. So I think it still takes a long process for you to determine the integral of secant. But for secant squared x, so I think we can derive this one because, we can integrate this one because the integral for secant squared is tangent x. So automatically this one is secant x. Okay, so getting the integral of secant squared x, that will be tangent x. Getting the derivative of u, that will be secant x tangent x dx. So again, verifying. So getting the derivative of secant x, that will be secant x tangent x. Getting the integral of secant x tangent x, it will lead you back to secant x. Same goes for this one. The integral of secant squared x is tangent x. The derivative of tangent x is secant squared x. So, correct na siya, di ba? Okay, so this will be uv minus integral of v du. So uv is secant tangent, secant x tangent x minus the integral of v du. So v du. So this becomes tangent x times secant x tangent x dx dx. dx. So this simplifies even further to secant x tangent x minus tangent squared x secant x dx. Okay, so next step is what do we need to do here now? So wag na stalemate no? Wag na takabaon sa isunod button. So unsa man yung masuggest what we need to do next? So tangent squared x and then secant x dx. So mag-lisod na siya no? Kaya wala ka ba sa button? Okay, so secant, so dv no? v du. Sa akin no? Sa muna kung kan. Okay, so okay. So tangent squared x, then secant x dx. So if we try to replace this one with its corresponding secant squared x minus 1, so what do you think will happen? So mabalik ta sa secant cube x, di ba? So mo repeat ta sa process again and again. Di ba? Pero kana siya is okay na siya. So let's try ito ko na. So this one becomes secant x tangent x, then minus so this becomes secant squared x minus 1 secant x dx. So upon distributing, so what will happen is we have secant x tangent x, then we have the integral of secant square cube x minus secant x dx. So kung tanaw nyo, magsamot ka problema no, kay mahimo siyang kuan. We don't have any integral for secant x pod, diba? So let's try to erase again. Okay, it's impossible, diba, if we try to replace it with its corresponding Pythagorean identity. So let's try another approach na pod. So muna siya ang kuan, ang kanindot sa calculus kay dili mo work ang isa, So you have to try another method. Okay, so if another integration by parts ta, diba? So murag if we try to force this one, to integrate, murag lisod siya, diba? So what we do here is let's try another integration by parts. So let's see if we can apply another integration by parts. So u and then dv baro na, di ba? So since we have tangent squared x, so murag wala man tayo derivative ana, di ba? Wala tayo derivative ana, di ba? Excuse. So ang saka na ron, di ba? Murag lisod na sad, no? So let's say we're going to put tangent squared here. So we cannot integrate fully tangent squared because there's no formula for that one. Unless we go very basic. So we don't have also an integral for secant x po, di ba? So medyo na-stale medyo na dili dapita na. Patabang sa tabi, patabang. So ako sa tanaw na kung andre notes. Kaya ako nakalimot sa go. Okay, so let's kusang tanawon diri ha. Okay. So actually na-solve din ni Day but kuan lang ko Day. Murag walang ko na kuan sa basic formula. Sa Okay, so actually there's an integral of kuanday. There's an integral for secant day. So that's why we cannot solve it the earlier. So sige lang ato lang ning i-try og solve balik kay marag madugay tada. So ako lang ning i-solve balik or just try solving it again. Kay nakalimot ko. So mana ang mga teachers kay dili pod perfect, diba? Kay masayop sad mi. Masay makalimot sad. Sige lang, so just try to solve this on your own and I'll solve it on my own again if I can answer this one. So amot lang if we answered this one before in my previous class or I wasn't able to answer this one. Okay, if I was able to answer this one, so I can still remember from memory. Yung wala di man siya makuha good answer. So basin wa sa ko answer ni before sa ako ang mga classes before sa atong face to face. Okay, so move on lang ta kay ito atong mabuhat, move on ra jud. Okay, so this one is obviously gone. Easy. So if you're going to ask me which one is complicated, the logarithm, the exponential, or the trigonometric, so it won't matter. But for me, I think it's easy that I have my dv as cosine x dx. So why I choose this one as my dv? Because if I place cosine as my u, I will have a negative value for du, and I don't want to deal with any negative symbols. So this one is my e to the power of x. So let's try if correct ba akong pag-assign. So v here, getting the integral of cosine, that will be sine x. Getting the du part here, this becomes e to the power of x dx. Okay. So next part is we're going to have the formula. So again, if you want to verify the answers, so derivative of e to the power of x, ex dx, integral is the same. Integral is sine x, derivative is cosine x dx. So again, by formula. So I think on number 6 is muna siya ang number 7, mark the same procedure. So let's try to see. So this one is e to the power of x sine x, then minus a v du. So sine x e to the power of x dx. So notice that we have to apply again your integration by parts. So going back to u and v, u and dv. So again, I'm going to use my sign here, sine x, to be consistent. This one is e to the power of x. So getting the integral of dv, this one is negative cosine x. Your du is e to the power of x dx. So writing the equation again, so this becomes e to the power of x sine x minus, so this becomes uv. So e to the power of, so this one is negative e to the power of cosine x minus the integral of v du. So negative cosine x, and then du is e to the power of x dx, then bracket. So simplifying the symbols, so negative, negative, positive, triple negative, 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 then negative. This one is negative gyapon. So this becomes e to the power of x sine x, then plus e to the power of x cosine x, and then minus the integral of e to the power of cosine, e to the power of x cosine x dx. So notice that ang kani siya ibalik ta dire, di ba? So unsa man ron, if we try to continue with the integration by parts, magbalik-balik ran ta up until di ta mahuman, di ba? So of course, if we try to solve equations, di ba, this one is the right side, so nag-equal sign ta, so equals the solution, equals the solution. So in BS Mathematics, what is normally done there is you write the equation on the left side, then on the right side is the solution. So e to the power of x cosine x dx, diba? Then equals this portion here. So notice that this one here is on the left, this one is on the right, this one is on the left. So we can combine them into one big equation. So may mo siyang on the left side, that will become 2 integral of e to the power of x, since this one is negative, and transposing it on the left side, it becomes positive. So meaning you have 2 integral of cosine x dx is equal to e to the power of sine x plus e to the power of x cosine x. Na. Parang ana siya, di ba? Then divide everything by 2. So the answer is the integral. So ako lang butang sa pababa kay marag 1 space. E to the power of x cosine x is equal to e to the power of x sine x plus e to the power of x cosine x all over 2 plus c. Na. So the final answer is e to the power of x sine x plus cosine x all over 2 plus c. Na. So for those of you who got confused what happened, so since I arrived at the same equation as the given, this one here, so I just transpose this one on the left side because again, in actual practice in calculating problems or making solutions, you always put the original equation and then you write on the right side the equal sign, then the right side is pure calculations. But since you don't have the luxury of time in writing the equation again on the left side, so muna magsintag right side, diba? Because what we're after is the final answer. So muna, since I arrive again on the answer, I mean on the given equation, so I just transposed it, and then this becomes this portion here. So ano mo siyang 2 times the integral of e to the power of x cosine x dx. So is equal to the right side. So notice that nawala na siyang napita, di ba? So this portion here has been combined with the left side. So meaning you have two integrals of e to the power of x cosine x dx. And just I divide it by 2, so that's why I have this equation here. Then don't forget the plus c because that's always part of the final answer. So I think muna siya ang nitabo sa inyong example. So let's try daw dv. Sige daw, let's try daw. So dv as sectangent, no? Sec x tangent x. Bitaw, no? Pwede sad, pwede sad. Okay, ako man i-combine dahil. So, sorry. So let's try to answer. So I think ma-answer na siya. Remember di ko. Sige, ato sa answer sa niya. Ako'y tip ani before dahil. So ano siya ikaw na. Ito na erase ni. So v, so I think the derivative of the integral of sec x tan x is secant x, right? And then the du for this one is secant squared x dx. Sige, let's try that way. So secant x tangent x, then secant x tangent x na po, no? Minus v du. Mabalik. Okay. Mabalik yapon siya dahil. Pero ma-positive siya. So mag the same siya as the seventh problem, but murag since ma-positive pa siya, and combine sa left side ma-zero siya. So murag there's something wrong dyan eh. Or there's something wrong with me. Sige lang. So let's try to continue so that we can finish ahead of time. And katong number 7 is magdungan lang tag kalabad sa itong uwa to. Magdungan tag hinuktok sa number 7 as you answer number 7 in your own respective homes. Okay, so let's try this one. So we have an algebraic term raised to the power of 2. Then you have an exponential term e to the power of 2x. So u and then a dv. Okay. So again, so if you have algebraic against exponential, so it's safe that your complicated term is the exponential term. Dx there, I mean dx. This one is dx. And the easier term is in the u parameter, because we can integrate e to the power of 2x. So this becomes 1/2 e to the power of 2x. And then du is equal to 2x dx. So again, by formula, so let's try to write it immediately. So we have x squared times 1/2 e raised to 2x minus v du. So integral of 1/2 e to the power of 2x times 2x dx. So cancel out 2, cancel out 2. Then we have 1/2 x squared e raised to 2x minus the integral of x e to the power of 2x dx. So again, we're going to use integration by parts because we still have algebra against exponential term. So writing it again. So of course, there are examples wherein you need to do multiple integration by parts up until you reach a basic integral of your VDU. So your u here is x. So to be consistent, let's follow the same steps as above. So e raised to 2x dx. Then so this one is v is equal to 1/2 e raised to 2x, and our du is equal to dx. Okay, so this time is we have 1/2 x squared e raised to 2x, then minus, so don't forget to put the bracket because you need to distribute the negative sign later, because since you are using another integration by parts, so there will be a negative in the second term. So uv is 1/2 x e raised to 2x, then minus a v du. So 1/2 e to the power of 2x dx. So distributing the negative sign, so this becomes 1/2 x squared e raised to 2x minus 1/2 x e to the power of 2x, then plus the integral of, so 1/2 e to the power of 2x dx. So since you can now integrate the last integral easily, so the final answer is 1/2 x squared e raised to 2x minus 1/2 x e to the power of 2x plus 1/4 e raised to the power of 2x plus c. Or if you want to group them together, grouping all the e to the power of 2x together, so this becomes 1/2 x squared minus 1/2 x plus 1/4 plus c. So both are correct. Okay? So for the shortcut, so na siya shortcut but only applicable if you have algebraic against any other function. So let's try to use purple. So again, the shortcut is only applicable in these types of examples. Kaning algebraic raised to any degree. So let's say x squared, x to the power of 7, x to the power of 8 against any other function, any function. So what you need to do here is you need to create a table here. Then on the right side is your one term and the right side is the other term. So I think on the left side that will be the derivative. And then the right side will be the integral. So derivative, so if you're asking me for the derivative, it's easy to derive the values for kuan, di ba? Na x squared. Then of course the other term is this one. So if we try to derive this one, so this becomes 2x, this becomes 2, this becomes 0. Sakto, di ba? Then this becomes 1 half e to the power of 2x. This becomes 1/4 e to the power of 2x. This becomes 1 over 8 e to the power of 2x. So the next step for you to do is for you to multiply in a diagonal manner. So ana lang pag-multiply, ana, padong ubos. So this becomes x squared. So notice that x squared times 1 half e to the power of x is the first term, di ba? Let's try to use another color para inyo yung ma-appreciate ang kanindutan eh. So the first term is 1 half x squared e to the power of 2x. So the same term here. Yeah, usually if we try to use a shortcut, so alternating operation na siya. So plus, then minus, and then plus. So we stop at 0 kay 0 plus at 0 times 1 over 8, 1 over 16 is 0 magyapon. So next is minus. So 1/4 times 2, that will be 1 half. Yeah, may mo siyang negative 1 half x raised to 2x. So the same as the second value here. Then the third value is 2 times 1/8 is 1/4. Then the operation is plus 1/4 e to the power of 2x. Then of course, ang plus c, ang vitamin C, inyo ray puno. Diba? Shortcut. So again, only applicable in algebraic functions raised to any degree. So akong point is x to the power of n times any term. Pwede niyo gamiton ani nga shortcut. Because the left side will reach a point wherein it becomes 0. So muna, we place the algebraic term in the derivative column because it will reach a point na mahimo siyang 0. Okay? So let's go to the last example. So u is equal to, then dv is sine 3x. Okay, so if you're looking at the example, so you're going to have a triple angle, sine 3x. And I think it's not advisable to put it in the integration part, dv. So let's put it here, sine 3x. Then the du for this one is 3 cosine 3x dx. dv for this part is e to the power of 2x dx. So marag ano ko ng color no? Marag paila lang gutom na. So 1 half e to the power of 2x na. So uv is equal to 1 half e to the power of 2x sine 3x, then minus v du. So that will be 1 half e raised to 2x, and then we have 3 cosine 3x. So I forgot the dx, so let's put the dx. So the equation becomes 1 half e to the power of 2x sine 3x minus, so that will be 3 halves, the integral of e raised to 2x cosine 3x dx. So if you're looking at the equation again, so murag mabalik ta sa integration by parts, diba? And I think this one is the same as example number 7. So so this will become cosine 3x, then du is equal to negative 3 sine 3x dx. Then your dv is e raised to 2x dx, and v is equal to 1 half raised e to the power of 2x. So this becomes 1 half e raised to 2x sine 3x minus 3 halves. So again, don't forget to put the bracket. So uv first, that will be 1 half e to the power of 2x cosine 3x, and then minus v du. So 1 half e to the power of 2x minus 3 sine 3x dx. So I think this one is the same as example number 7. So again, don't forget to distribute 3 halves. And then this one is diri sa pikas ana. So may mo siyang 1 half e raised to 2x sine 3x, and then minus 3/4 e raised to 2x cosine 3x. So minus, it's still minus. So 3 halves times 1 half times 3. So that will be negative 9 over 4. The integral of e raised to 2x sine 3x dx. So notice nga nibalik ta sa given equation, di ba? And we have 9 over 4 as the coefficient. So if we try to transpose that one on the left side, so it will become e to the power of 2x sine 3x. So transposing 9 over 4 on the left side, that will be plus 9 over 4. Integral of e to the power of 2x sine 3x dx, so na siya dx there, is equal to 1 half e raised to 2x sine 3x minus 3/4 e raised to 2x cosine 3x. So taas kay siya, di ba? So combining, so 1 plus 9 over 4, that will be 13 over 4. And then dividing by 4 over 13. Diba? So kani siya, ang kani left side will become 11 over 4, I mean 13 over 4. Then divide by 13 over 4. So on the right side, so the answer, so ako na shortcut, okay, one space. So the answer will be, so the answer will be 2 over 13. So just correct me if I'm wrong. Sine 3x. And then minus 3 over 13 e to the power of 2x cosine 3x plus c. So I think muna siya ang answer siguro. So just try to verify it with Symbolab or try to verify it on your own. Okay, so do you have questions so far for the procedures for the integration of parts topic? Okay, so if you don't have any questions, so see you all on Monday, and I'll be discussing the last part of the advanced techniques, which is the integration by partial fractions.